Hello and thanks for joining us for Sustaining Us here on KLCS PBS. I'm David Nazar. Rail transportation, trains, are used to transport just about everything: people, fuel, raw materials, manufactured goods. And while electric trains using renewable energy can offer a more carbon-free journey, the commonly used diesel engine, well, that can be a problem on the environment. Certainly not as bad as planes or the tens of millions of cars on the road. However, trains still produce things like nitrogen dioxide, carbon dioxide, and particulate matter that greatly contribute to pollution in our air, water, and soil, as well as what many claim is climate change and global warming. And then many health experts have warned diesel emissions cause respiratory health problems, even cardiovascular problems, possibly cancer. So how do we remedy the tried and true old school diesel motor and the giant locomotives that house them? Well, how about recycling? We recycle bottles, plastics, cardboard boxes, so why not locomotives? Well, an Orange County company located in Fullerton could be onto something.
We recycle everything. Cars, paper, trash. When it comes to the end of the life of a locomotive, why would it be any different?
My name is Dave Cook. I work for Rail Propulsion Systems, and we're developing retrofit battery conversion systems for switcher and passenger locomotives. I founded the company with Ian in 2014. I have a background in test engineering, race cars, airplanes, jet engines, and now locomotives. The locomotive was figured out a long time ago, and we're just integrating modern technology where it fits in the locomotive. What we're working on is removing the diesel engine and putting in a battery pack that provides the energy needed to drive the electric motors that are there. And what we're doing is we're using these locomotives in places where batteries work. Switcher locomotives in small rail yards that don't go long distances, and passenger locomotives that start and stop constantly, kind of like a hybrid electric car. So we're currently working on the only battery locomotive that's operating in North America that is on a full-size locomotive chassis. The battery technology is finally caught up in the past decade. There was a lot of work before where they tried to have the batteries do things they shouldn't. Now is the point in time where combining these things together just makes sense. Reason a small company is doing this is the bigger companies are continuing to sell iterations of the old technology that they've invested in, and this is an industry where equipment lasts 35 years, so until we find a way to get equipment out there and show that it lasts 5 to 10 years, it's considered experimental, and people in the industry itself are hesitant to risk their careers trying out new technology like this.
My name is Ian Stewart. I am president of Rail Propulsion Systems. We have developed and now have in service the only all-electric locomotive in the world. We've started this company and developed this locomotive specifically because we recognize that rail equipment is one of the largest producers of pollution in metropolitan areas. The way we've applied this locomotive and our technology in it allows us to provide a zero emissions solution that is equivalent in utility to the existing locomotives that are out there doing work every day. Our 999 locomotive may look brand new, but it's actually over 50 years old. And that's because a locomotive is the most durable and sustainable vehicle that's ever been developed. So we're able to take existing locomotive chassis, upgrade them much like remodeling a house, and equip them with modern batteries and modern electronics and make them work just like an electric car would. We have a much more sustainable approach because we're not having to manufacture all of this heavy steel, and we're able to reuse it and keep it from being scrapped and recycled, which also takes a lot of energy. So I'd like to take you on a tour of how we take a legacy or vintage locomotive that may or may not be currently in service right now and convert that to a zero emissions modern locomotive. So our process at RPS starts with finding an existing locomotive, much like this GP9 switcher locomotive, that may or may not be in use currently, and assess it for the condition of the chassis and the trucks and the traction motors and the brake system. If it is a worthy candidate, or a core we call it, to do a conversion, then we go back and remove the roof and the sidewalls and remove the engine and generator, which is a very large 1,000 to 3,000 horsepower engine, diesel engine and generator, and replace it with batteries and electronics. So we're now inside the cab of an F-59 locomotive, and this locomotive was built in the 80s, and these are the controls, and all of this is retained in our conversions. So all of the control interface for the operators stays the same for safety reasons. So any certified engineer, train engineer, can come on board any of our converted locomotives and operate it the same way they would operate any other diesel electric locomotive. You are now in the engine room of an F-59 PH passenger locomotive. And this locomotive is equipped with a 12-cylinder V710 engine manufactured originally by EMD. And it's a diesel locomotive engine. It is 8,520 cubic inches and is about 3,000 horsepower. And what we do is we take this engine that's connected to this very large generator up here, and we remove the roof of the locomotive, and then take a very large crane and lift this 60,000 some pound engine out of the locomotive. So this is an F-59 PH locomotive like you've just seen, but this one has the engine removed already. We're getting ready to remove the generator, so you have this large space, and this is where all the batteries that will power this locomotive go. And in order to remove any of this equipment and install our batteries, locomotives like this have removable hatches or roof sections. And you can see here that we've actually left this section of the hatch, which is the cooling hatch, off. And the hatch that's in front of me here that was over the engine is the dynamic brake hatch, and it removes in much the same manner. So locomotives are fairly simple to disassemble. They're just really heavy, so it takes a lot of special equipment and a lot of special training to be able to do it properly. Once we've converted the locomotive, the result is something similar to this. Our 999 locomotive, which is built on a GP38 chassis, which is just a slightly newer version of the GP9 chassis that I just showed you. The trucks and the traction motors and the brakes are all retained and rebuilt to new. So how do we charge an all-electric locomotive? Well, it's very similar to an electric vehicle, where you have a charge port on the vehicle that's connected to an electricity source, plug in the connector to the vehicle, electricity to transfer through from the source into the battery system. Where the engine and generator used to be is now floor to ceiling, front to back batteries, over 900 of them. And the key to our technology and why it's so sustainable and important is this is a platform that's over 50 years old. This locomotive is over 50 years old, but it is now zero emissions, like new, and we're using batteries out of pre-used electric vehicles. So when an electric vehicle can no longer go the distance it needs to, they remove the batteries. They would normally throw them away. We can now acquire those batteries and continue to use them for years longer in locomotives. So this makes this locomotive one of, if not the most sustainable vehicle on the planet. The goal is to apply the technology that we've developed on a larger scale and build up fleets of switcher locomotives and passenger locomotives for commuter rail to allow them to operate at zero emissions with better performance and reliability than they currently have. We believe we can do this in Southern California by the time the Olympics come in 2028.
Joining me now to discuss this further is Paul Dyson. Paul is with Rail Propulsion Systems. He's been working in the railroad industry in a variety of capacities since the late 1960s, both in the UK and the US. Paul is a self-proclaimed staunch environmentalist working over the decades on sustainability and enviro projects to help reduce highway congestion and ultimately reduce air pollution. Paul, thanks so much for being here.
It's a pleasure. Thank you.
Quite a resume. I hate to age you, but you've been working on this for 5 decades. Tell me what you've been doing.
I'm afraid so, yes. I couldn't find the exit, so I've been involved in operations and planning and analysis, and more recently in finance, and then for the last few years as a consultant.
Obviously, we had environmental concerns back in the 60s and 70s. There was a formation of the Environmental Protection Agency. However, where you're concerned, were these mega environmental issues even back on the radar then, Paul? And obviously I'm sort of comparing that to the hypervigilance of environmental issues today.
I think from my point of view, of course, I was just a teenager then, and I very much focused on the specific issues of transportation. I'm sure there were some deep thinkers around that were concerned about early stages of global warming and air pollution and so on, but I was pretty much a one-horse pony, a one-horse circus, I guess, and focused on transportation.
So bringing things back here to Southern California and departing the UK, you know, here in SoCal, obviously if you don't have a car, you're kind of out of luck. I mean, really the car is the lifeline to get anywhere in this town. What are you folks doing over at Rail Propulsion Systems in terms of advancing transportation options, both here in the Southland and through the US, so we're not so reliant on our cars, many of which are these monster SUV four-wheel drive gas guzzling polluters?
And the key thing that we're trying to do in our own small way is to improve the efficiency of the delivery of the systems, if you like. We're strong supporters of Metrolink, obviously, and they built up a system over the years reliant on diesel engines. And while the diesel engine is tried and true, been around a long time, we think it's time to move on to a cleaner and more sustainable alternative, which is some form of electrification. What we focused on, two things. One is cleaning up existing diesel engines to see them through this transition phase into electric traction, and then working on battery systems, first to enhance the diesels, and then after that to be a standalone system of hauling the trains.
Yeah, and you mentioned the word diesel engine as being tried and true. That it is. However, still today there are so many trains and trucks out on the roads and the rail that rely heavily on that diesel engine. So is your plan practical?
Absolutely. Electric traction, electric propulsion has been around almost as long, in fact, in some cases longer than the internal combustion engine. Just been as a really chance circumstances that led to the widespread use of the petrol engine and then a little bit later on the diesel engine. But we don't see any real issue with using our technology. The key of what we want to do is to use sustainable, renewable energy to transmit that to the trains, and then use that energy to power the trains. Instead of hauling a power plant around, which is powered by fossil fuels, you gain your energy from solar, from wind power. You can transfer it by different means to the locomotive, and then you can haul the train. What we're focusing on is batteries, and I'll get into that a bit more in a moment.
Well, speaking of batteries, aren't you taxing the electric grid? I mean, obviously you're reducing air pollution with that smoky diesel engine, but what about the energy grid?
No, not at all. In fact, we planned like a three-phase system, if you like. Use the batteries to power your electric automobiles initially. They can only work up to a certain level or down to a certain level of efficiency. We can then reuse those batteries, recycle them, put them in our locomotives, use down to the next level of efficiency. After that, we can put them into stationary containers or storage modules, which can be recharged overnight with solar power in the daytime, wind power at nighttime. Then they can charge up the locomotives when they're in storage overnight. So you have a whole system here of continually reusing components for as long as possible.
What are the, I guess I should say, challenges with the rail propulsion prototype you're working on? Because obviously I'm sure you're trying to get all the transportation agencies, all the rail industry, basically anyone who'll listen to believe in your product, in your prototype.
It's a startup and it's fun every day. It's a real challenge. Money's always a challenge and credibility is a challenge. Yeah. Say that we have the expertise. I have no doubt about that. We have smart people here in Southern California, in the whole of California. We're perfectly capable of coming up with these systems just as good as anything that the Japanese or the Germans or the Chinese can come up with. So we know we have the expertise. Our guys actually mostly come from Cal Poly, so very much homegrown. As far as the agencies are concerned, the key for a passenger business is it's got to be reliable. So people won't use it if it's not. And so they look to us to come up with a reliable product that's going to run the trains on time every day. And that's what we're working on, is developing prototypes and testing them so that we can reliably say, yes, we can do the job.
30 seconds. Answer me this question, if you would be so kind. Is there even a future in passenger rail, given all these new technologies like autonomous vehicles?
Absolutely. The passenger rail is unique in its ability to move large numbers of people and to do so in safety. The safety features are improving all the time. The wheel has been around 3,000 years. So the basic technology, all of these systems use. But the passenger train has evolved so much, even in my career, over the last 40 or 50 years. The improvements in reliability and passenger comfort and control systems and so on. Yeah, there's a great future for it.
Paul Dyson with Rail Propulsion Systems, thank you so much for being here.
Thanks for the opportunity.
And now from the recycling of locomotives to the recycling of electronic waste. Many of us take our old cell phones or old computers that we don't use anymore to a local e-waste recycler so we don't harm the environment. However, do we really know if some of these devices are in fact getting recycled at all? Producers Katie Campbell and Ken Christensen with public media partner EarthFix have our story.
So everybody, this is scenario one. We're buying equipment. We look around, see what they have, and we start haggling over the price. So any questions?
No, sir.
I think it's right up here about a quarter of a mile.
Jim Puckett is leading a team that's going undercover to find out what actually happens to electronics that are sent to U.S. recyclers.
Most of the public still thinks a recycler is a recycler and that they're going to recycle it right there in America. They're really exporters, and they don't care what happens at the other end. Shows us 10 meters out.
Puckett is the founder of the Basel Action Network, a Seattle-based watchdog group that investigates the afterlife of electronics.
We're basically trying to stop the rich countries from dumping their hazardous waste on the poorer countries.
In this case, Hong Kong.
But they're running.
Running away?
To get inside, a local driver and translator posed as e-waste buyers.
老板，我们过来买货的。我就说是想要看一下那个电子器件的那些零部件嘛。之类的。
With people buying new computers and other electronics more frequently than ever, electronic waste is now the fastest growing waste stream in the world. On top of that, it contains toxic materials that can poison people and the environment. This investigation began months ago, when Puckett's team put GPS tracking devices inside 200 old computers, printers, and TVs. Then they dropped them off at locations across the country, at recycling facilities, donation centers, and electronics take-back programs, including some of the industry's most reputable companies.
We sat back and said, where are they going to go? And the little devices went out and spoke to us, saying, this is where I am.
Puckett's group partnered with Carlo Roddy of the Sensible City Lab at the Massachusetts Institute of Technology.
Tracking is really the first step in order to design a better system. One of the surprising things we discover is how far waste travels. You see these kind of global e-waste flows that actually almost cover the whole planet.
Each device traveled an average of about 2,500 miles, and around a third of the tracked computers were exported. Of those, most ended up here. Hong Kong is home to one of the world's busiest ports. Ships deliver more cargo than is possible to inspect. As a result, Hong Kong has a reputation for being a transit point for illegal trade and smuggling of all kinds.
Turn right onto Tin Fog Road.
Most of the exported tracked devices led Puckett to a little-known part of Hong Kong called the New Territories.
It's really a frontier. It's really cowboy land out there.
Puckett followed one tracked printer here to a place that calls itself a farm.
Farmland.
Farmland? Yeah, that's a great farm in there. You would have no idea that there was a huge scrapyard there until you look over the fence.
Inside, they found printers being taken apart by immigrant workers.
I'm looking for asset tags to tell me where the material came from. I look for the environmental harm issues. I look for the workstations to see how those workers might be exposed.
Many of the workers handle hazardous material without protective gear. One concern, printer toner, a probable carcinogen.
There's no protections of this labor force. There's no occupational laws that are going to protect them.
Jackson Lau is the head of the Hong Kong Recycling Association. He runs a licensed recycling facility in the New Territories, and he says the junkyards in the area that import e-waste are unlicensed and unregulated.
只不過停留喺一個分類拆解個過程，咁整個呢個處理過程咧，其實就唔係一個好完善嘅設備嘅，咁形成咗咧有啲冇價值嘅嘢咧會堆放咗喺香港裏邊咧。老細。
Look at the tubes, many tubes thrown on the ground here.
The white fluorescent tubes light up LCD screens. Each of them contains mercury, and even a tiny amount can be a neurotoxin.
Day in and day out, these workers are completely oblivious to this hazard, are smashing these. The tubes are breaking right in front of their faces, and mercury is very toxic.
I asked him that if he knows the wipe tubes are dangerous. He has no idea.
The United States is the only developed nation that hasn't ratified an international treaty to stop first world countries from dumping e-waste on developing nations. Other developed nations set e-waste collection mandates and require electronics manufacturers to pay for domestic e-waste processing. Further, the United States has no federal laws requiring electronics to be recycled. Half of states allow electronics to be dumped in landfills. John Shigarian is the CEO of Electronics Recycling International, the largest e-waste recycling company in the United States.
It takes hundreds of employees in each facility to do the real work of electronic recycling.
He says that some recyclers are exporting to cut costs because in the last 2 years, their biggest source of revenue has plummeted.
At the height of the market, when we would go to sell steel, plastic, aluminum, gold, silver, palladium, copper, we were getting 14 to 15 cents a pound more than we are today.
Dell Reconnect, an exciting program that makes getting rid of old technology easy.
Dell was the first major computer manufacturer to ban the export of non-working electronics to developing countries. They partnered with Goodwill, allowing people to drop off old computers of any brand for free to be refurbished or recycled. The electronics are either dismantled on site or sent to Dell's recycling partners. Dell says that more than 400 million pounds of e-waste has been diverted from U.S. landfills because of their program. But the Basel Action Network and MIT's investigation concluded that tracking devices placed in old computers and dropped off at participating Goodwill locations ended up in Hong Kong, China, Taiwan, and Thailand. Beth Johnson manages Dell's program.
If there's something that did not follow the system, we would certainly want to know about it, and we would certainly take corrective action.
In a written statement, Goodwill Industries said it's committed to responsible recycling and encouraged its member organizations, which are autonomous, to review their contracts with Dell. Back in Hong Kong, Puckett finds more clues to the scale of the problem.
The laptop with an LCD screen ending up here in Hong Kong and new territories from the Los Angeles school system. Unbelievable.
Puckett finds electronics from U.S. police departments, jails, hospitals, and libraries.
The government is always trying to save taxpayers' money, so they are obliged in some cases to always do the cheapest thing.
For now, market forces are driving e-waste exports.
Throwing it on the bank here.
Without a federal law banning the export of e-waste, there's little incentive for the industry to change.
Thanks, Katie Campbell and Ken Christensen with EarthFix for that report. For more information about our program, just click on klcs.org and then click Contact Us to send us your questions and comments or story ideas so we can hear from you. Thank you so much for joining us for this edition of Sustaining Us here on KLCS PBS. I'm David Nazar.